Hey, welcome back to the channel. Good to see you again. Thanks for joining. Today on the bench I have kind of a unique thing here. It's a realistic STA-2500 digital synthesized AM/FM stereo receiver. That's a big mouthful because this is kind of a early digital receiver from the days when everybody was analog and then they wanted to make the big shift over to digital on their receivers and tuners. This has got, this is actually a really nice example of it. It's nice, clean condition. It's not beat up at all. I don't see any damage on it. It looks very pristine, and it's nicely optioned. It has some good options. It's got tuning memory for your digital tuner, signal strength meter. This one has the fluorescent vacuum fluorescent display power meters, kind of like the Pioneers did in the early days. It's 2 tape loops. It's got 2 phono inputs, auxiliary TV. It says here auxiliary TV. So I guess they were anticipating early days of stereo television, FM and AM. And then you have tone defeat button, bass, mid-range, and treble, which is kind of unique because it has the mid-range in there. So it's nicely optioned, nice receiver. Realistic makes okay stuff. It's all right. Once you get it tuned up and running great, they do sound good. Not the best. Like I've heard other, like Sansui and a few other Yamahas, they really put their effort into good sound. Realistic puts more of their effort into reliability, believe it or not, and service. The service information for these is great, and they had a huge service network when these things were offered for sale. You could pretty much take it anywhere in the world and get it serviced by a realistic service depot. But let's try this out and give it a test. This is a client unit, so we're going to do some repairs. It's actually got a polarized plug on here. I wonder if that's been replaced. Having a polarized plug is kind of unique for this era. So I plugged it in, drawing 0, which tells me there's no backup supply, power supply. So let's turn this thing on, see if it does anything. I got it on auxiliary. Let's turn on a signal source. Okay, got 1000 hertz tone. Okay, turning it on, and it's working right away. Right channel is very quiet. We're drawing 50 watts too, so that's not cool. Something going on with that right channel, and it keeps climbing in power. I'm going to shut this off. And I noticed our display meters were pegged at the 120 watt mark. Don't want to leave it on too long because I think it has a problem. Let's try that again. Let's try this again. You can hear the power up. It's really 50 watts. Shouldn't be 50 watts, that's for sure. Let's try FM. Tuning. Right channels are really quiet. Yeah, this thing keeps climbing in power. It went up to 63 watts. So I think there's a problem with the amplifiers, especially the right channel. Alright, so let's get into this. It's going to have the full thing with the recaps, everything, and it's going to come out the other end of this video working perfectly. So let's get started. Alright, got to remove both side panels, and then there's 3 screws along the back, and then the lid is free, and it looks very nice and clean. Very good. So we got a lot of stuff going on here. Got a power supply board already on top here. It looks kind of toasty. And then we have underneath a board with our power amplifier, protect relay here. This is all tuner down here, and this looks like a phono stage up here in this corner. And then we have tuner display here. This is all integrated circuits on this board. And we have, oh, I can see cracked solders already. Let me give you a look. Give you a zoom in and a look. I don't know if you can see these joints here. These are all really heat stressed. This one's cracked, this one's cracked here. And this is like, there is like a little power supply underneath here, a regulator or something. That's what's creating this heat right in this area. So we'll have to address that. This power supply board, a lot of heat here, right in this area too. Probably got a bunch of dead caps right in this area. And we'll have to look at that as well. I think everything's working. I think it's just a matter of the excessive current consumption is probably an amplifier that's out of bias adjustment. I don't know what's going on with that right channel. Might be something serious. Might be dead transistor. I don't know. I'm not going to guess at this point. I'm just telling you what's going through my head at the moment. So let's get the bottom off. I think it has a removable bottom. It does, yeah. So we can access a lot of the receiver from the bottom. Can't really see underneath. I'm just going to pull two screws out here, and we're going to move this board so we can have a look underneath it. Okay, will this allow us? Okay. What's going on here? That looks odd. So there's our bulk filter caps, but this does not look good. This, I don't know what that's from. I think they're okay, but let's have a look at this board. This board here is loaded with cracks. This is cracked. This is cracked. This transistor's cracked. This transistor's cracked. This one here is not even connected. That's a transistor, yep. You can wiggle it and you can see it moving. This all has to be resoldered because all this heat. Yeah. I got a fair bit of work ahead of me here. Time for a look at the belly of the beast. Here's our date code. Why isn't this coming off? Oh, I gotta remove these as well? Are you kidding me? Gotta remove all the feet as well. Here's our date code. You can read that, November of '84. Mid-80s receiver. Looks like I'm the first person in here from the dust signature. I think it's ever been worked on. What we got going here? We got the bottom of all the boards. This is our tone board. This is our switching for tuner. This is our speaker switches here. It's all power amplifier here. And yeah, it does look pretty baked in some spots. Some of these transistors are, you can see the cracks around the pads. I don't know what this is. Oh, that's tuner. Yeah, it should be fairly easy to work on. Just a matter of going through, recapping, and then we'll troubleshoot after we've done the recap. Let's figure it out, because I have a feeling recap's usually 50-50. Sometimes they fix what's problem is, sometimes they don't. So I don't know. To me, troubleshooting first before our recap's done is counterproductive. Spend your time recapping. If you're going to do your recap first, and then troubleshoot after. That's my thoughts anyways. I know a lot of people won't agree with that, but they have their way of doing it and I have mine. So let me get started. Okay, a bit of an update time here. I got these two caps out. These are 10,000 microfarad, 71 volts. Kind of an unusual voltage, unusual size too. They're 40 millimeters by 50 millimeters tall. So they're kind of difficult to replace. They have a really kind of a rare pinout for not for caps this size, but for caps in general. So to replace these would be kind of a, I don't know. Don't need to replace them though, because they are testing absolutely fine. Let me see here. And if we test this, I can show you what they are coming back at. So they're coming back at about 9,500 microfarads, 17 milliohms ESR, which is perfectly fine for this cap. I'm going to leave these in circuit. Here's the other one. Let me short this out first. I always short these big ones out because they can carry a residual charge. Okay, here's the other one. 96. Once it settles, it's about 98, 9700. So yeah, these caps are fine. I'm going to leave those and put them back in. But these other caps are completely garbage, with the exception of one. These are all dead. These are out of the power supply. Some of these are out of the audio amplifier as well, so they're dead too. Anywhere there's a cap and heat zone, they're coming back dead. These are, I think they're Nichi, what are these things? Nippon Chemcon from, yeah, they're branded Nippon Chemcon. But they're still cooked. They're garbage, so they all have to be replaced. And I'm working my way through that right now. Even on this card here, this is the vacuum fluorescent display card that has a large vacuum fluorescent display, has the power meters and the digital readout. These caps are going to be cooked as well because there's a little regulated supply here. And then I'll just replace all these just for safety. One thing I got to pay attention to here on this thing is the connectors they use. They use the same connector, like for example, I got three 3-pin connectors here. They got different color sleeving on this end, but there's no way to match it up to the board. It is in the manual, but I like to just take a Sharpie and mark them so I know where they came from. Most connectors are marked with a number, like this is marked CP2, so I know my connector with the CP with 2 on it. This one has 2 on it, or that's 7. Where is it? 10. Well, whatever. It doesn't matter. It's keeping these wires straight, because if you plug in the wrong wire into the wrong connector, you can end up blowing something up, like an expensive chip or you know, some part that you have difficulty fixing or impossible to fix. So this is basically the display board. It's in 2 halves. This half here is all power meter. This half here is all control for the FM tuner and the display. So there's a chip here. It's an NEC chip 1703. It's a pretty common chip. And all its support circuitry, the clock, and the power supply, everything's on this board. So I'm going to make sure this is all good. And then I'm going to get rid of these bodges here on the back. We can do that with surface mount components and make these go away. That's just nice. And I'll just keep plugging away at this thing. This one's done. This board's done. Another thing I'm going to do is I removed these 2 3-watt or 5-watt resistors from this board, because all it's doing is cooking the board. And these are 2 56 ohm resistors in series to drop voltage for one of the regulators here. I'm going to eliminate this, and I'm going to attach a resistor to the heatsink, and it's going to dissipate its heat into the heatsink, and I'll just run 2 wires to this board, and then we'll have this a lot cooler, and these caps won't die in the next 30 years like they did. Alright, update time. Okay, I got all the caps replaced in this thing. There's quite a few of them, and to be perfectly honest, I've never seen a receiver with so many dead caps in it. Incredible. Like dead, not just a weak or failing. Oh, there's a lot of weak and failing ones too, but I'd say maybe 10% of the caps are okay. A good 10-15% of them are completely dead, open circuit, failed, you know, complete. and then the rest were just down in microfarads, and ESR was way through the roof. So this is a good thing for this receiver. This will bring it back. I'm just at the point where I'm starting to put things back together. I got the phono stage reinstalled, tuners completed. The power amplifier has all been, I resoldered the back. A lot of cracked solders as well as dead caps. So this thing was a basket case. I'm surprised it worked. So I'm looking at the relay right now and testing for contact resistance, and to my non-surprise, look here, I'll show you what we get. Okay, so there's one set of contacts on that side. Let's see if I can get some power to this coil and make this thing click. Okay, so we're getting 600 ohms, 300 ohms. Yeah, that's our contact resistance on that side. Not very good. Let's try the other side. Now we're getting 3.5 ohms on this side. It's a lot better. 9 ohms. Okay, enough of that. So this relay is not very friendly for cleaning. Got double sets of contacts, and I'm going to need to get in there with a piece of paper and some cleaner. Why is this side bent back and that side isn't? I don't know if somebody's been in here before me. I don't think so. But we'll get these contacts cleaned up. I might have to even use sandpaper if it comes right down to it, but we'll do what we have to do, and then we'll get this back together. Okay, my cleaning with paper and contact cleaner didn't even budge the needle. Didn't do a thing. So I started using 1000 grit, and this is the result. 1000 grit. I got 14 milliohms on the one side. On the other side, let's flip this around and test it right now. If it's good, I can put it back in. Okay, what do we got? 19, 17. That's good enough for me. Alright, put this back in. Put this back in and we'll call her a day. Okay, so what I did is I mounted two resistors here. This is two 60 ohm 10 watt resistors in series for effective resistance of 118 ohms. This is a dropping resistor that was found on this board. There's two resistors here. I'm removing them, and I moved the resistors off board so that they can heat to their desire and burn whatever they want. They won't be burning the board anymore. So I'll run two wires. I have a connector here, and I'll just run the wires over and connect it up. Now, this resistor isn't the one I had planned to use. I actually ordered a resistor for this application, one that's a chassis mount, and it never arrived. And I'm still waiting. It's like 6 weeks now. This project's been on hold because I've been waiting for this resistor. So it's not coming. I decided to move ahead without the resistor, make up a mock-up of what I needed for this application, and this will work good. This will conduct heat. I got a gel pad underneath the resistors to transfer heat to the aluminum, and this will stay nice and cool. This will stay cold, and everything's good. So I'm at the point where I can put everything back together again. I have the receiver all ripped apart. You can see I've gone through switches, I've gone through the pots, I've replaced all the caps. Everything's done. All I need to do now is reassembly and test. So I'm going to get busy putting this all back together today. Hopefully I can get it all finished today, and we'll bring it back in. We'll do some testing, see what else needs fixing on this thing. There's a few things you should know about this Realistic receiver. Realistic does a really good job of building reliable gear, and I'll show you a few reasons why. If you look here, you'll see there's a temperature sensor bolted to the heatsink. Now that's not for bias control or bias compensation. That is a temperature sensor for if the power amplifier overheats, it's going to shut it down. And that's one sensor bolted there. You got to remember to take that apart when you're opening this up, and make sure that's secured when you're done. Also, they have another temperature sensor here for the transformer, and this is it here. This gets bolted to the transformer, and this senses the if the transformer overheats, it also shuts it down to prevent permanent damage. So I'll connect this back up. So that's all good. Another interesting fun fact is this area here, there's actually 4 amplifiers here instead of 2. And they have 2 phono inputs, 4 amplifiers. So 1 amplifier for phono input 1, 1 amplifier with 2 channels for phono input 2. That way they don't have to do any really low level switching here. It all the signals come in, and then they can switch it after it leaves the board. Which is kind of a nice touch, I guess. You have just a few extra parts, and removing the switch at the front end here simplifies it and makes it more reliable. So when I first opened it up, these temperature biasing transistors, they weren't contacting the heatsink at all. They had compound on them, but they were back. There was nothing tying them down to the heatsink at all, and they were just floating in the air, not making contact. I think that's why when I first powered this up, the power consumption started to climb, and it continued climbing, because this wasn't thermally connected here. So what I did is I drilled 2 holes, and I'm just going to put a zip tie to hold that down, and I'm going to get here, I'll show you. So I'm going to get one of these. This is a thermal gel pad. I don't know if it's silicone or what it is, but it's really soft and it's mushy. And they use these on top of chips to make a thermal connection between the chip and the heatsink. So I'm just going to take probably about this much, and I'll make 2 pads, and I'll put this under the transistor, and then I'll zip tie that transistor to the heatsink. Okay, let's see if I can do this on camera here. I've got a zip tie installed. I'm just going to take this pad, I'm just going to install it under the transistor. Straighten it up so it looks nice. Kind of a block of gel, some kind of gel. Okay, now just get my pliers here, and I can grab the end of the zip tie, and I should be able to tighten it down and zip it in place. There, I think that'll work. That transistor's in there, and it's connected to the heatsink thermally. And I'll just do the same on the other side, and away we go. Okay, I'm all back together. There is no adjustments, no biasing adjustments, no DC balance adjustments. Everything's automatically adjusted, I guess, or compensated for by the circuits themselves. So we're going to just power it up, and we'll see how it works. Now, I remember when I first powered this thing up, it started sucking close to 60 watts on the outlet. And I went to the service manual and read the specifications. When this thing's running properly and idling, it should only consume about 38 watts. And so that 60 watt number I was seeing before, there must have been an issue. So I don't know if that will come back, because we haven't changed anything other than the caps, and we haven't done anything else. So we might still have an issue with this. We don't know. So I'll connect some speakers, a tone source, and maybe I'll connect the load, and we can do a power test if everything's running good, and we'll see how this thing works out. Okay, so I'll connect it to a pair of speakers. Got power, speakers A. AM, so let's try this out. 40 watts, and the relay clicked. 41, 42, it's climbing up.
पर आप अगर फाइट कर रहे हो ना कि यार नहीं आज तो मेरी दीदी को ये करना है बिकॉज करवा चौथ ऑफ कोर्स आई अंडरस्टैंड यार बहुत कुछ है करने के लिए.
It's working. Power consumption is still climbing up. 52 and climbing. 40, 54. Wow. That's not cool. What is that noise? $62 watts, still climbing. The right channel is a lot quieter. Let's try our tone. 70 watts. So we got a problem in the right amplifier. $67 watts. What is going on here? A little electric shock if you touch both these heat sinks. 70 watts. Where's all this heat going? Okay, so we still have some troubleshooting here. Something is wrong with this amplifier. 70 watts of power. I don't feel any heat on the heatsink, that's the problem. Where's all this heat going? Nothing's hot. Got a bad transformer? 71 watts. Everything's cool. We got some weird distortion on the right channel. Okay. Let's try and figure this out. Alright, got a load connected, got the scope connected. I'm going to get a voltmeter going here. Got a voltmeter going on the left channel. I'm really mystified as to what is drawing all that power. So we have a bad transistor somewhere in the circuit. Come on, connect. Okay. AC volts, let's turn this thing on. What is going on here? I got my probes connected. Let's turn it on. We're still working on tone. We got no trigger. Channel 1. There we go. Okay, so what's going on here? The low, that's the left channel. The right channel. Look what happens when I turn the balance control all the way to the left. It kind of goes inverse. See that? And then I attenuate the left channel. It doesn't do that. Let's turn this up. Let's trigger off the right channel. Okay. Let's see if we get how much power we get out of this thing. The left channel is doing the same thing. The balance control. Maybe I got a bad connection here. Okay. Turn my probes on 10 times, don't I? Yeah, I do. Alright, going up to clipping. Here we are, clipping the left channel. Take it down a bit. Right about there. Got 25.2 volts RMS on the output. 279 watts going in. Right channel's clipping too. See if the balance pot. Let's measure the right channel. Okay, going up. Clipping's right there. Down a bit. It's hard to see this spot. Right about there, I'd say. 25.3 on the right channel. So the right channel is putting out the right power. $280 watts on both channels driven to max. Let's turn it down. So why is it doing that? We got a problem with the volume control. So that's 0. If I start bringing it up, the right channel's attenuated, the left channel's coming up, and then when I hit a certain spot, they both come into play. Something's wrong with the volume control. And check the, I might have to replace it if it's damaged. Yeah, look at that. Full volume. I'm clipping on both channels at the same time. If I turn it down, the right channel's attenuated, the left channel's still going strong. And look at this. After some high power stuff, we got our idle is at 30 watts, not 71. This thing's really playing mind games on me, or what is it doing? Okay, here's a schematic of the input circuits of the STA-2500. So here's my AV right, the AV left is way up here. This line comes in, goes to the tape monitor switching that's up, not shown here. No, this is tape monitor switching, sorry. This is the function switching. And then it comes back down on these two lines, I believe, left and right. And then it goes into the tape monitor switching. And this is all tape monitor. And then from there, it leaves and left and right and goes into the volume control. The volume control has a volume tap. And right here, here and here, there's our volume tap. And then after the volume control, we have a grounded balance control. The center wiper is grounded. And when you shift it from left to right, it grounds out either the left or right channel to make the other one come up. And everything here in the balance circuit's working. I tested this out. Problem is testing some resistances on this volume tap on the volume pot. I'm getting different readings, and this line goes up into the loudness switch. Look at that, loudness switch. So maybe I have a problem with the loudness switch. Let's see here. This line goes up to the switch and then is grounded through an 8.2K resistor. This volume tap goes up through here and is grounded through an 8.2K resistor. A 2.2 meg resistor. If this is open, this is 2.2 meg here, and this flows through. I don't know why they have 2.2 meg, but I'm seeing quite a difference here on this volume tap. So I'm measuring right now, I'm measuring the volume tap to ground, and I'm getting 55K. And if I manipulate the loudness switch, it goes to mega ohms. Okay. If I let the loudness switch out, I'm getting 26K. So this switch is definitely flaky. If I manipulate it and bump it, we don't ever get 8.2K, we get something higher. So this switch is pretty much done. Let me check the other side. Check the other channel. Okay. Loudness switch is out. We're getting 12, 11K. Push it in. We're getting 56K. That's odd. If I hit the mono, it drops a bit. So something's wrong here. This should be 8.2K. And when I open, it should be open circuit, not 56K. So something going on in this board here, the one behind this one. This board here, the switches are all messed up. And I also noticed the mono switch. Where is it? Oh no, that board is way at the bottom. No, it's not that board, it's in the behind. So right here is the switches I'm talking about. This is the loudness switch, this is the mono. And something's wrong with this. I might have to remove this board and replace these switches. They might be too far gone. Looks like, yeah, let me do some testing here. I'll see if these switches are holding up or if they need to be changed. Okay, I'm pretty sure I tracked it down to this switch. The loudness switch is open. I'm getting really weird readings from these switch contacts, and I think that's a bum switch, and we're not getting any continuity through it. If I check from ground, I'll show you here. You can see this, I hope. This is on one side of the switch, getting 56K. And it doesn't change when I hit the switch. The other side, oh now it's 47 mega ohms. See, on this side I got kilo ohms, this side I got mega ohms. So this switch is open, I believe. It's not making any contact whatsoever. I'm going to take that out. I'll take them all out and clean them because they're probably all the same condition. So I don't think I have fresh ones to replace it with. Come on, go. And I'll see what I can do with that. So apparently you are able to take these switches apart. First step would be take off this retainer clip. You have to spread it a bit to get it over the shaft because it goes on like this. And then remove the spring. And then after you remove the spring, the lid can come off. So the lid hooks on in the back like that, and then it just drops on like that. And the spring keeps it on. So that's where you can't remove it from prying at the back. You have to remove the spring first, then you lift the lid off, and then you get your contacts. Are pretty dirty, they're black. and I'm gonna do a polish on these and get this switch back in service. I'll do all 5 of these switches. Okay, boys and girls, we got a problem here. This is the volume control pot. It is a 200K. You read this here. I don't know if you can see that. Go into focus. 200K pot. B times 2. B meaning audio taper, I'm assuming. I don't know. I'm not up on this. They got A and B. A is linear and then B is audio taper. But here is one channel of the pot's resistance. It's supposed to be 200K. Measures 172. We got glare. Okay. Here's the other side. 170. Okay, that in itself isn't a problem because they're both pretty balanced. But look at this. If I take, well, let's go from the outside here, which is the minimum. Okay, from minimum to the volume tap, I've got 17, 18, 27 mega ohms. Got a bad connection there or something. It's mega ohms. Let's see the other side. Here we got 56K, which is normal. So this volume tap on the back pot here is open. Let's take this off. It's really easy to take off because it's just got some tangs here. Let's open this up. Let's have a look inside and see if we can do anything for it. I don't think so. It's more than likely this rivet is not connecting, but we'll see. Maybe I can crush the rivet down some more, make a connection, but then that's no guarantee it's going to survive any amount of time. So let's open this up. Could be an open trace too. Okay, here we go. So there's where our tap is at, and it looks like a pointing device. Looks like we have our track. This is minimum right here. Goes up to about 1/3, and then after that it's all. Let's see if we can figure out with another meter here with different probes. See if we can figure out where the break is. Okay. I touch there. I'm getting 17 ohms. Getting 70 ohms. So everything, the break is right here actually. And how do you fix that? You don't. It's open. Open. See here I got 300 some ohms, which is normal for this track. Because it's not a metal track, it's more like a carbon track. And then here I got open circuit, open circuit. So there's broken connection right here between this track and this track. There's not much you can do for that pot aside from replace it. Let me see if I can see anything. There's no way to join those two. It's really odd that that coating is opened up right where the connection is. I wonder if this side is the same. Can't really see it. Yeah, it's the same. So it's kaput. What do? We got to replace it. Find a replacement. 200K pot with volume tap. I'm going to see, and it has to have a D shaft, and it has to be 40 millimeters. 40 millimeter D shaft. Let's see if I can find one. I'll hunt one up. If I can't find it, I think the alternative would be to use this volume pot but disconnect the volume tap and disconnect the loudness switch. If I remove the volume tap, it'll allow the potentiometer to work normally but without the loudness switch and the loudness function. Alright, bad news. I looked on all my usual sources, DigiKey, went and looked on Mauser too, AliExpress. You can get a lot of different parts on all these places, but nothing that resembles anything close to this. The real problem is the audio taper. You can get potentiometers, stereo potentiometers in any value you want, shaft. This is called the flattened shaft. I call it a D style. You can get any kind you want, but when it comes to the audio taper, I don't see any that offer that as an option. I have bought new ones that do have the audio taper, but not in anything that will resemble a fit for this. So I propose to go ahead and use this pot. The pot itself is working, it's just that one audio tap is broken. So if we disconnect both audio taps and run with it, we'll have no loudness tap for the loudness switch. And I don't think that poses too much of a problem. Let's see here. Here's my pencil. Here's the tap here, and it runs up to essentially the loudness switch, and that's as far as it goes. This one here runs up to this. The mono switch is independent. So if we cut this off here and here, there's no connection to this loudness switch. So yeah, it's not going to ground out. The only other alternative is to scavenge a pot out of another receiver. but to find the right value and the right shaft length and everything like that would be a chore. I did look through my scrapped receiver parts and I didn't find anything like this. So yeah, it's difficult. Replacing pots ain't that hard if you're not dealing with this volume tap. But once you get that volume tap involved, it's almost impossible. Okay, it's back together again for hopefully the last time. Now what I did is I cut the 2 wires for the volume tap, or the loudness tap on the volume pot, and I cleaned these 8 switches and put it all back together. Let's try it out, turn it on, and my goal here is to have 2 channels equal in volume as I turn up the volume. So let's try this and look at that. So we've got equal balance now on the amplifiers. Even if I press the loudness switch, it does nothing because it's disconnected. Mono. These other switches are active and effective, but the loudness is disabled. So you're going to have to turn up the bass and treble if you want loudness, or turn down the mid-range. That's good. I'm pleased with that. So now we have to figure out why this thing keeps climbing in power consumption. It's at 57 watts now and climbing. While it's doing that, I'm going to measure the current on this pair and this pair to see if we can figure out where this extra current is going, or extra wattage. So I just have to find out where my emitter resistor is, and then I'll tap onto it. So I think it is right here. Come on. Right here and here should be the emitter resistor. Got 108 millivolts. That's probably the one, the bad one. Okay, this one here, and this one, 117 millivolts. We're at 67 watts now. That's really odd. It's odd that both channels are doing it. Let me see if I can figure out why it's doing this. I'm going to look at a schematic and see if I can figure out what's going on here. So one thing I noticed here, when I first turn the amplifier on, when it's cold, it's drawing like about 30-35 watts, and then it rises up to about 70 watts, 65-70 watts rather quickly, and now it's dropping back down again. I think once it warms up and compensates, it kind of backs off and throttles back on the power. See, now I'm down to 60 watts and it's dropping 59, and this has dropped too. This is millivolts across both emitter resistors. So this was up to 118, now it's back down to 95. If I check the other channel, 80. Now you see, and the heatsink's getting quite warm. Down to 58 watts and dropping. So once the heatsink warms up, I think it kind of stabilizes. Is that normal? I don't know. I've never seen an amplifier do this kind of weird behavior where it shoots up in power consumption like that and then settles back down. In the service manual, in the specifications, I go there and it reads, it said it should be 38 watts at idle. And that's what I'm expecting to see. Now it's 57, going down. This heatsink is fairly warm. It's probably about 40 degrees. Yeah, exactly, 40 degrees. So, is that normal? I don't know. It might want to hit a state of equilibrium and want to just stay there. I'm going to still look at the schematic and see if I can figure out if that's normal. Okay, I'm working on this problem with the biasing where it overheats, or it doesn't really overheat, it just really runs hot. There's no adjustment for the bias, and as far as I can tell, it's all controlled by this thermistor here. There's this transistor that's mounted on the heatsink. It's a 2SC945. So I've taken out and tested these transistors, these are the outputs. I tested these, tested this, and I tested these two. And all these transistors are fine. They're within their gain ranges. I checked these resistors. I haven't checked these 10s, but I will. These are fine, that's fine, that's fine. All these resistors are fine. None of them are at tolerance. I'm looking at you, Mr. Thermistor. So I got one out here, and we're going to test it right now. I don't know what value it's supposed to be at, at room temperature. So let's turn this up. So just from me having it in my hands, it went flaky connection. Before I touched it, it was at 2.295 ohms. Now, kilo ohms. Now, if this thing's drifted and it's gone out of tolerance, all I really need to do is know. So if I heat this up, it drops. So maybe it's drifted high or open, and I think all I need to do is add a resistor across it to shunt it and put it back into its range where it needs to be, because I think it's sensing the temperature of the heat that's by these transistors, and it's trying to regulate the bias to keep that heat at a constant level. And that should probably be about, what, 5 degrees above room temperature, I would say. 25 degrees Celsius, is that normal? 30, that's a little too warm. And then if you have the right amount of current going through your... Yeah, I think I'm going to shunt this. Okay, I'm looking at this thermistor, and it's got no markings on it. Nothing. And you go in the service manual, it has a part number. That's it, has no value, no nothing. So I have no idea what this thermistor is running at. But we're going to find out here. So we got 21 degrees Celsius right now. I haven't touched it with my hands because that upsets it. So I'm just going to connect up my meter and see what it reads. I got a dodgy connection here. So 2.4K, almost 2.5K. Now, when this amplifier warms up and it reaches its happy spot, what I mean by happy spot is it kind of equalizes to a certain temperature. The current going through the transistors heats up the heatsink. The heatsink warms up. The thermistor senses that heat, and when the heat rises to a certain point, it realizes that and it throttles back on the current, which kind of self-regulates. So the happy spot for this amplifier, when I was just testing it, is around 40 degrees Celsius, which is too high. It shouldn't be that high. It should only be about 4 or 5 degrees above ambient. Plus the current through the output transistors was too high. We had over 100 millivolts for going through two 0.39 ohm resistors. So that's almost 0.8 ohms. So that's a fair amount of current for a 0.8 ohm resistor. If I do the math, I equals E over R. So let's say we had a 110 millivolts divided by 0.8. It's 137 milliamps. Is that right? I think it is. 137. That's quite a bit. We shouldn't be that high. We should be down around 50 milliamps idling current for those transistors. So we got a thermistor here that, look, I think it's out of tolerance. It says 2.4. Let's heat it up, and it drops. Okay. So I think this thermistor has gone high with age, high in resistance with age. So what I propose to do is I propose to put a trimmer potentiometer across it, and we'll adjust it down to see where it gets its happy point at a cooler temperature. So I got a 100K resistor here. I'm going to put it across this thermistor, and we'll see how much it drops. Not very much. So it's at 2.28, and if I put this, it drops by about 50 ohms, let's say. That's a good start. We can use a 100K trim pot, and we can start put it in there and trim it, and then we can watch the behavior of the amplifier, see how it warms up, what temperatures it reaches, what current it gets through the emitter resistors, and we can adjust it. And then I think leave the adjusting pot in there so that if this thermistor drifts more, we can adjust it. But we'll have to adjust something, because we can't let it run that hot. It's wasting too much power, it's getting too hot, and it's not good. Okay, so I got the thermistor reinstalled, and I also tacked on a 100K pot across the thermistor to shunt it, and it's wide open, so it's on the highest ohmic reading. And when I start turning this, I'm going to bring the resistance down, and we're going to bring the current up through that thermistor, and that should help us adjust the idle current for the output pair. So what we're doing here is this. I don't know if you can see this. Let me zoom in. So here's our output. We've got our two emitter resistors. They're both 0.39 ohms, which for a total I measured at 0.744 ohms. Now we want the current through here to be reduced. I think as a starting ballpark figure, I think 50 milliamps will be okay. We can adjust it up and down to whatever we need, this current at idle, just by tweaking the pot here. So what do we want to see for a voltage across two 0.39 ohm resistors? So we use Ohm's law, 50 milliamps, 0.5, no sorry, clear, 0.05 for 50 times the resistance is 0.744. So we should be looking for about 37 millivolts across here, and that'll be a good start. And that will, like I said, we can adjust it up and down from there. So let's connect up a meter and put this thing to work. Now, when we first turn it on, everything's going to be cold, and it could be quite high. So let me plug this in. I have a watt meter going here as well, so that we can see what's going on. Move this over. You can see both meters, hopefully. It's plugged in. Turn this thing on, obviously. Okay, let's turn on the power. This is at 27 millivolts. And their power consumption is low, 32 watts. And things are going to start warming up. We already shot past our target 37 millivolts. 37 might be too low. We might have to go a little higher, depending on how much heat we're putting into how much we're turning on those transistors. So we're just watching it climb up here. It's 45 already. I'll just let this run. Okay, I'm back. I had a little cock up there. I slipped the probe and did some damage. And the damage was a couple output devices were completely gone, so I had to replace those quickly. Now we're back in business. Now let's try it again. Let's turn this on and let's monitor the current. Oh, wattage is a lot lower now. I wonder why. I'm going to watch this go up, and I'll see where it plateaus, and then I'll bring you back in. Okay, it seems to be plateauing right around 127 or so millivolts. Now I remember this went up, when I did this test yesterday, this went up to 70 watts. So this number probably higher yet. Let's try adjusting our little trim pot here and see if it makes any adjustment to the bias current. Oh yeah, it's coming down. We want it to come down. It's probably about 3 or 4 times higher than it should be. So let's drop this down to, let's say, about 50 for now. I don't want to cut it too low. And just let it stabilize there. I'll let it stabilize at about 50 milliamps. Now you also got to remember the other amplifier is running at full bias, and I haven't made any adjustments to it. So this part's going to heat up the heatsink and cause problems on this side. You have to do both sides at the same time to kind of keep the heat down. But the heatsink is already getting warm. I'm just going to let this stabilize and see how it goes, and then I'll bring you back in. Okay, it's been on for another 10 minutes or so. So this is still climbing up very slowly. It's around 55 millivolts now. I think what I should do is I should make an adjustment to the other channel so the heatsink isn't so hot. It's quite warm right now, and the other channel is pumping all the heat into the heatsink, and this one here isn't pushing much current at all. 55 millivolts. I could actually turn this down. We'll figure out what the ideal optimum value will be, but let's just turn this down a little bit more. Oops, wrong way there. It's very touchy when it gets close to the sweet spot. Let's turn it to about 30. Let's go with 40. 42, close enough. Okay, let me make the change to the other channel and I'll come back. Okay, I'm now attached to the other channel. I got my trim pod installed. Let's power it up and see how it... plug it in first would help. Okay, let's power it up. Drops to a lower value. It's 20 watts now, and we're going to climb here. So I'll let the camera go and we'll see how high this side goes. Probably goes up to about 120 as well. Okay, it seems to be stopping right around 108.5 millivolts. Kind of plateauing here. So it's dropping a bit, then it goes up a bit, and it starts. Okay, so I'm going to make the adjustment on this channel. Can't see if my hand's in the way. Take this one down to 50 as well. Too low. Okay. Our consumption is down where it should be, 35 watts, 36 watts. We got proper amount of bias current. I was going to let this stabilize and see what it does. And then I think what I'm going to do is I'm going to remove these two trim pots and we're going to measure it to see what the value is. And then maybe we can reconstruct the circuit to accommodate a trimmer. And we might have to adjust this resistor's 3.3K. We might have to drop that to a 2.2 or an 1800 and then make the adjustments. I don't want to adjust everything by shunting the thermistor, because what you're doing actually is when you shunt the thermistor is you're actually taking away from its sensitivity. I want to make adjustment to the resistor that's in series with it as well, and that'll help keep the sensitivity of the thermistor also and give me an adjustment range. So I might end up doing both, shunting the thermistor and adjusting that resistor. Sorry. So I'll let this go for a while and balance and settle, and then I'll come back and we'll see what it does. So what I've done here is I removed both 3.3K resistors that was in series with the thermistor and replaced it with a 2.2K, so dropping the resistance down by 1.1K. I removed the two trim pots and I got my meter connected across the emitter resistor. Let's test and see how it warms up this time. Starting off quite low, which is lower than it should be. This, you're probably going to get crossover distortion when it's this low, but as it warms up, it slowly climbs up. We'll see how high it goes, and if it goes too high, we'll have to add the trimmer to trim it down a bit and keep it in that range that we want it at. So I'm just going to let this go and then we'll come back. Okay, so it's been on for about 7 minutes. 7 minutes I'd say, and it climbed up to about 28, 29. That's a nice range to be in. I think I'm going to leave that alone. We're consuming 30 watts. Let's check the other channel. It should be pretty close to the same. Just got to be careful. I don't want to blow up any more transistors. It gets expensive if you do that too much. Yeah, we're 29. That's perfect. I like that. I'm going to leave that alone, and I'm not going to add a trim pot. I'm just going to leave it like that. See, this is barely warm. Can barely feel any heat coming off that. That is good. So I'm going to leave it at that. Consider it fixed. Okay, here's a quick block diagram. Look at the LA1240. This is the AM chip, AM radio on a chip. You got RF amplifier 1 and 2, converter, IF amplifier 1, 2, and 3, detector, and then you have your automatic gain control and meter drive. So we're getting out of pin 12, we're getting a bunch of nonsense and noise. So I'm thinking we can actually put a signal into pin 13 like we can get from my signal generator, 455 kilohertz modulated, and tack it in there through a capacitor and see if this is working. I have a feeling this is buggered right here. The detector, it's making some awful noises and making some god-awful sounds. So we can inject a signal at pin 13, and we can also inject a signal at pin 8 too, a smaller signal, because you have, you know, amplifiers working. See if they're working, and let's do that. See if this chip is bad or not. I have a feeling it is. I got chips on order. They're about $2 a piece. If they're not counterfeit or not, I don't know yet. We're going to find out when we get there. So let's go do that. Inject a signal at pin 8 and 13. Okay, I think I got it all set up. I tacked the capacitor onto pin 13, and we're going to connect the signal generator. Ground it out here. And let's turn this thing on. Let's go. See if we can. Yeah. Doesn't want to take a station. Okay. Doesn't matter because we're going to put an IF signal in. Let's turn up the volume on that. Quite a strong signal, but it is coming in. You can see the strength meter. So that is working. That's odd. Let's go back to pin 8 and inject a signal. I'll have to remove the cap and move it. So I'll be right back. Okay, I'm back. Connected to pin 8. Let's turn this up. Alright, so I'll give it about quarter volume. Turn up the signal. I've got nothing, absolutely nothing coming through. Hang on. Still, it's working. But why isn't our tuner working? This is really odd. That chip might be still good. Ha! It's a mystery now. Still trying to figure out this tuner problem, AM tuner problem. And look what I discovered here. When I tap this coil, it breaks into oscillation. Even from the magnetic of my screwdriver, kind of changes the... It's that awful noise. And that, yeah, maybe it is just the magnetic from the screwdriver setting it off. But it's like it's breaking into an oscillation. I wonder if that coil is bad or if there's a... It's adjustment. When I adjust it, I peak it, it seems to want to break into an oscillation. Alright, we're back on this 2500 today. Now I did finally be able to source a AM chip. It's a LA1240. I'm going to pop this in, see if this is our problem. Maybe this chip is bad. I'm thinking it is. Typically these chips are pretty reliable. They don't go bad unless they, suffer something drastic like a lightning strike or catastrophic power supply over voltage or something like that to the effect. But they're pretty robust. But we're going to pop this one in and see if this cures it. So let me solder this in and try it out. Okay, this thing's going to start giving me fits pretty soon. I went and replaced this chip. Oh, sorry, get my big mitt in the way. Replaced this chip, and the exact same problem exists. So it's not the chip. It's got to be a component here that is not working. Now, what I did also after I replaced this chip is I went through a full alignment on the AM. It responded to the adjustments, but this thing is so deaf it couldn't barely. I had to really jack up the output on my signal generator before it would pick up signals. Now, I'm beginning to suspect one of these three coils is either has a open winding or a short. So I'm going to scrutinize these three coils. I'm going to pull them out and disassemble and have an inspect or maybe test them. I think there's got to be a problem here. I have already tested the main loop stick, the bar antenna, and it's working fine. It's been adjusted. Everything else has been adjusted or it's been checked. All these transistors, or no, all these capacitors and resistors, there's nothing really wrong here. So I have to dig deeper into this. I have a feeling it's one of these coils. It's got to be. So I'm going to start pulling them out and scrutinizing them. Okay, I got the cap back in. Listen to this crackling noise. It sounds like silver mica disease. That's why I suspect it's a cap somewhere in this circuit here. Now there's some ceramic tubular capacitors inside these inductors and transformer cans, and I think that might be one of the problems. But you can hear it's crackling and fizzing and hissing. So yeah, I'm just ready to pull my hair out here. Okay, have a look at this. I'm going to scope pin 4 on this IC chip. Here's pin 4. You can see the noise on this signal corresponds to the scratchy, fizzy, poppy stuff I'm hearing. Now you're probably wondering, what is pin 4? Well, pin 4 is this. I'll show you. So here's the data sheet for this chip. This is an LA1240. Pin 4 is the output of the RFA amp 2. So what goes on pin 1 comes out of pin 4. It goes through capacitor and goes back into the converter. This chip has two RF amps. Looks like pin 1 and pin 2 are the inputs. Yeah, so either it's something on the front end that's messed up, or maybe this cap, or I doubt it's the chip because I replaced the chip, and nothing changed as far as symptoms. It continues to do this, so it's got to be an external component. Now I'm guessing it's something in the front end, the tuning end of things. I'm going through and I'm pulling these caps out and checking them for capacitance, and if they seem suspicious, I'll replace them on the spot. There's no problem there. But yeah, this is a mess. This cap here between pin 4 and pin 7 might be suspect. Might be leaky. I'm gonna try keep digging here. Okay, I found one problem. I don't know if it's the problem. This is a trimmer cap, and I'm checking for leakage on it, and it's gonna start ramping up the voltage here. Let me reach around, and you can see when I turning up the voltage, we got current leakage. So this is definitely a problem. That should not have any leakage whatsoever. So I'm going to replace this cap. Okay, I've been fighting with this thing for the last 3 days. I'm going to give up. I don't often give up on something, but this is possessed. This thing is possessed, and I'm pretty sure there's something wrong with the main controller chip for the tuner. First I thought I was chasing an oscillation, because look at what happens when I tune up and down on the AM band. It's actually picking up stations. Very weak. But notice how they're spread out. There's no selection. Okay, let's go up a little more. See, I shouldn't have the station covering 3 different frequencies like that. And then when I go down, something messed up with this thing. I thought it was an oscillation, but when I go down, turn this so it doesn't make sense. There we go. And it gets into this area. And it starts doing this. Now, I don't know if that's an oscillation or if that is the vacuum fluorescent scan display scan signals getting back into the audio or into the phase lock loop or something to that effect. I think that's what's happening. Let me show you here on the scope a few things. Alright, going to scope pin 28 of this controller chip. You see we have, this is the AM, let's see what it is, AM oscillator output. Now if I go up or down, see how it breaks out of oscillation? And it's down around, that's 100 Hertz sine wave. You see how it's breaking up? Okay, that is normal oscillation. If I go down, see it falls out of oscillation again, and keep going on the tuning dial. Definitely a problem, something with the phase lock loop. See, that's working. I'm not picking up a station at that spot. Where we were at 780, let's keep going. 790, 800. But this thing's messed up. Now I think the problem lies with the controller chip, not the tuner itself. I've replaced the AM chip, the LA1240. I replaced it, no change. I've gone through and I've checked a lot of these caps, they're all good. I did replace one tuning capacitor, but that was at the front end, and I think that eliminated some noise when I was tuning it. You could hear some scratchy noise. Everything else just seems to be working here around this area. So that's why I decided to just give up on this thing. just eating too much of my time. Now, let's go look at FM. So for the most part, FM works. Let's go up the band or down the band. We're not getting any stereo. It's picking up interstation noise, but the S meter is at full bars. And then the stations comes through on the noise. Okay, let me feed a signal in and I'll show you something else. Okay, I got the station set for 98.1, generator set for 98.1. Let's turn up the amplitude and bring this. Okay, alright, so you can see that, I hope. Now that's a 1 kilohertz tone. What I'm going to do is raise it up to 19 kilohertz and it should get a stereo beacon light. So let's do this. There's 19 kilohertz right there, and we have no stereo. And I'm going to adjust the 19 kilohertz oscillator, which is VR303. So let me adjust this. And you'll see it'll click in stereo and it'll make these squeaky noises. But when it does kick in, it's like it's beating against something. You shouldn't be getting that squeaky noise. Oh, there it is there. Okay, let me adjust the pilot tone. Going down. And I fell out of. Here's 18.2 kilohertz. Going up again. 18.6. 19. 19.4. 19.7, 8, 9, 20 kilohertz, still locked. 20.4 kilohertz, 20.5 kilohertz, it loses lock. So it is working, but it's not working very good. And my potentiometer is right at the range of adjustment, so I might have to look at that circuit and see what's going on there. They might have a bad resistor or something. So I might be able to get the FM working, but the AM is trash. Yeah, and I'm unable to get the stereo to lock on any station. I'm also picking up a weird noise. Let me turn this off here. Let me turn off modulation. Hear that rumble noise? That's coming from the FM tuner. I don't know if you can hear it. Turn up the volume. That. And I happen to think that is something in the phase lock loop that is messed up on the FM. But tuning this thing is junk. Well, there it is. I'm done with it. That's as far as I'm taking it. It's actually a nice unit. I really like the style of it. It's got the wood sides and the brushed aluminum front, black top. Looks really sharp in person. But it is an old digital tuner design. It's one of the first ones that Radio Shack made, and you know, it's heavily relying on chipset. If there's a problem somewhere in the chipset, I don't know. I think it is a problem with the chipset. But like I said, I'm not going to take this any farther. It's it's a great sounding amplifier, and we fixed a lot of problems. We had a bad volume tap on the volume control, which is unrepairable, so we left that alone. And we got through that. We also fixed up biasing problems that this thing had. Needed a full recap. The power supply was baked and wasn't working properly, so we refurbished that. We replaced all the caps and got that going. And this will be a good sounding receiver. Well, it's not a receiver anymore, it's more of an amp because the tuners are dead. But you can't win them all, right? So I'm going to leave this one, and if I had more time I could probably sort it out, but I just don't have the time to donate to one of these 80s receivers. You know, we got problems with parts aging, and we got problems with trying to source parts for it, and yeah, I just don't have the time to fight over a badly behaving tuner, so I'm just gonna let it go. Alright, that's it for this one. Thanks for watching, and we'll see you on the next one. Take care.